Hello and welcome back to Computer Science Tutorials, where today we'll be looking at encryption. Encryption is the process of encoding a message so that it can only be read by the sender and the intended recipients. Data encryption is the act of changing electronic information into an unreadable state by using algorithms or ciphers. Encryption can be used to protect the user's identity and privacy. If we are ever being watched, inadvertently or not, we can hide our data by using properly implemented crypto systems. According to cryptographer and security and privacy specialist Bruce Schneier, encryption works best if it is ubiquitous and automatic. It should be enabled for everything by default, not a feature you can only turn on when you're doing something you consider worth protecting. The encryption of data and its importance was well known before the times of computers. A very early example of this is the Caesar cipher, which was used within the Roman military to send sensitive information. It is a very simple system where every letter in the message is substituted by another one a certain number of letters down the alphabet. For example, if we're going to move the letters by 2, A would become C, B would become D, and Y would become A, and so on. This would mean that a message such as hello there, HELLOTHERE, would become JGNNQ VJGTG. There are two different types of encryption, symmetric and asymmetric. A symmetric system is a simpler system where both the sender and the recipient use the same algorithm with the same cryptographic key. With the advent of computer systems, symmetric encryption has been too easy to crack using even mere brute force attacks. And so, asymmetric encryption is used instead. Asymmetric encryption, also called public key encryption, makes use of key pairs to encrypt messages. Instead of having one key in common, a key pair is generated containing one public key and one private key. The public key can only be used to encrypt messages, and the messages can only be decrypted with the matching private key. Using an asymmetric encryption system, if you wanted to send an encrypted message to me, I would have to generate a new key pair and send you my public key, which you would use to encrypt the message. You would then send the encrypted message to me, and I would decrypt it using my private key. If I want to send you an encrypted message, I would have to receive a public key from you, and you would need to use your private key to decrypt the message. Of course, this is all done by our computers. The public key can be given to anyone, since it doesn't allow you to decrypt any messages. On the other hand, it is very important for the private key to remain in the creator's hands only. In this case, a two-way communication is taking place, as both ends need to generate a key pair each, and send each other their public keys, so that they can encrypt messages that only the other end can decrypt with their private keys. In modern computer systems, the most common symmetric encryption algorithms are DDS, or Data Encryption Standard, and Blowfish and its successor, Twofish. On the other hand, the most common asymmetric encryption algorithms are RSA and AES, or Advanced Encryption Standard. Most of these algorithms can use different key lengths, ranging from 40-bit to 4096-bit. The bigger the key, the stronger the encryption, but the slower the encryption-decryption process. Having said that, we've covered just about all you need to know about encryption at GCSE level. Make sure to subscribe so you don't miss more videos from us, and make sure to like if you've learned something new, or dislike and tell us why in the comments below. See you next time.